This video is about factoring polynomials, so let's begin. Now, the first method we're going to use is factoring the GCF, or the greatest common factor. So, with our first question, we have 6x minus 2, right? Now, what is one common factor, or the greatest common factor we can divide from 6x and 2, right? That would be 2, right? We can divide 2 from each. So, 2 goes on the outside, and then inside the bracket, we're going to divide 6x by 2, which is 3x, and negative 2 divided by 2, which is minus 1. So we'd get 2x multiplied by brackets 3x minus 1. Now on to the next question. We have 5x plus 25. What can we factor out? We can factor out a 5. So 5 goes outside the bracket. Then we have 5x divided by 5, which is just x. And we have 25 divided by 5, which is 5. So we'd get 5 multiplied by x plus 5. Now our next question, we have 4x squared minus 2x. We can factor out a 2x. So 2x goes on the outside, and inside the brackets, we can divide 4x squared by 2x, which is 2x. And negative 2x divided by 2x is just minus 1. So this would be our answer right here. Now for the next question, we have 7x cubed plus 28x squared. So the greatest common factor would be 7x squared. And inside the brackets, we do 7x cubed divided by 7x squared, which is just x. And then 28x squared divided by 7x squared is 4. So this would be our final answer. Now let's see if we have a question like this, right? So we have 3 terms. So this is a trinomial. We have x squared plus 6x plus 8. And in this method, we're going to try and find 2 values that multiply to 8 and add to 6. So to help me remember this, I like to make this little x chart, right? On the top, it has to multiply to 8, and it has to also add to 6. So the 2 terms that do this is 4 and 2, right? 4 plus 2 is 6, and 4 multiplied by 2 is 8. So I'll do 4 and 2. To set up trinomial factors, we do brackets like this. So it's this x squared, and there's no coefficient to it. It'll just be x and x. And then the 2 values is positive 4 and positive 2. So we do x plus 4 and x plus 2. Right, now on to the next example. We have x squared minus 1 plus 12. Setting up our chart, it has to multiply to 12 and add to negative 1. Right, the 2 values that do this is negative 4 and 3. So we set up our equation like this: x minus 4 and x plus 3. Right, now let's see what happens when we have a coefficient in front of the x squared. So in this equation, or this expression, we have 2x squared plus 10x plus 12, right? So what we can do is, let's first see if we can factor out a greatest common factor. Since all terms, or all coefficients, is even, we can factor out a 2. So we can do 2x squared plus 5x plus 6, right? Now, everything inside the brackets right here, we can factor on top like we did. So we can do our chart here. We need to find a term that multiplies to 6 and adds to positive 5, right? 2 terms that does this is 3 and 2. So we'll set up, we keep the 2, and we do x plus 3 and x plus 2, right? And this would be our answer. Now, let's go on to the next example. We have 2x squared minus 12x plus 16. So the greatest common factor is a 2, so we can factor out a 2. So we'd have 2 in brackets x squared minus 6x plus 8, right? So now we're going to factor everything inside the brackets, right? So let's set up our chart. We need to find values that multiply to 8 and add to negative 6, right? 2 terms that do that is negative 4 and negative 2, right? Negative 4 plus negative 2 is negative 6, and negative 4 multiplied by negative 2 is 8. So what we'll have is 2x minus 4x minus 2, right? Now, moving on to the next two examples right here. We have 3x squared plus 13x plus 4. Now, since there is no common factor, we're going to have to use another method. And in this method, we're going to multiply the leading coefficient here to the end term right here, right? So 3 multiplied by 14 is 42. So let's set up our chart. So instead of just two terms that multiply to 14, if we have a coefficient in front of the x squared and we cannot factor that out, we have to multiply it by the term without x. So 3 multiplied by 14 is 42. So we need to find value that multiplies to 42 and adds to 13, right? The two terms that do this is 7 and 6. So what we'll do is we'll do 3x squared plus 7x, right? Because we're splitting the 13x. So we'll do plus 7x plus 6x plus 14, right? And now we're going to split this expression in two. We're going to factor this separately and factor this separately. So we're going to get, so for the 3x squared plus 7x, we can factor out an x. So we'll be left with x, 3x plus 7. And then here we can factor out a 2. So plus 2, 3x plus 7, right? So now here we have these two, the 3x plus 7, the same. So we can leave that as 1. 3x plus 7. And we have x and 2. So we're going to combine it into its own brackets. X plus 2, right? So effectively, we're just factoring out 3x plus 7 out of this entire expression. So the answer would be 3x plus 7 multiplied by x plus 2 in the red box right here. Moving on to another example, we have 4x squared minus 15x plus 9. Let's first check if we can find a greatest common factor and factor out the 4. All right, since we can't, we're going to do like we did before. We're going to multiply the 4 by the 9, right? So 4 multiplied by 9 is 36. So we need to find two terms that multiply to 36 and add to negative 15. So the two terms that do this is 3 and 12, or negative 3 and negative 12, right? So I'm going to split the 15x into 4x squared minus 3x, right, minus 12x plus 9, right? Now I'm going to factor these two separately, the 4x squared minus 3x and the minus 12x plus 9. Starting off with the 4x squared minus 3x, we can factor out an x, so we'll get x brackets 4x minus 3. And now I'm going to factor out a negative 3 out of the negative 12x plus 9, because that's its greatest common factor. So we'll have negative 3 and then 4x minus 3. Now since we have the 4x minus 3 twice, we're going to factor out that out of the entire expression, right? So we're going to get 4x minus 3, and we can combine the coefficients, so x and negative 3, into 1. And this would be our answer right here, 4x minus 3 multiplied by x minus 3. Now, let's go over something we call the difference of perfect squares. Here, if the first term right here, the x squared, and the second term right here is it could be perfectly squared, right, with no decimals and whole numbers, we can set up the equation like this. Let me go in white. X minus and x plus, right? So following the minus, following the plus, is going to be the same number, right? So we just need to square the 64, right? So 64 squared is 8. So we'll have x minus 8 and x plus 8, right? This only works if we have an x squared and a term with that, cannot be factored from the x and can be perfectly squared. So moving on to another example, we have x squared minus 9. So that would be x plus 3, x minus 3. Now, you can pause the video and do the next two on your own, right? So we have x squared minus 16. That's going to be x plus 4 and x minus 4, right? 16 squared is 4. And now onto the next question, the final example, we have x squared minus 8. So we're going to get x plus 9 and x minus 9, right? We went over factoring polynomials for Algebra 1. If you guys have any questions, please feel free to comment down below or let me know. I hope you like this video and subscribe. Thank you for watching.